Good afternoon. Can you hear me clearly all the way? Okay, good. Fantastic. 3:15. Let's get started. In a conference and trade show where you have 100,000 people, tens of thousands coming in, 1,000 exhibitors, you taking time to come to attend this meeting, I really appreciate your time. I hope I give you your time's worth, that you're here for 55 minutes. The idea is to give a broad overview of what factory digital twinning is all about, and also what our company does to further enhance that concept and make it practical for small and medium-sized businesses. I have with me two of people from my company. Here's Henry and there's Ryan. Just so I'm introducing them to you in case you want the presentation to be sent to you. Just give them your card or give me your card, and we'll email it to you at the end of the day. Okay, with this, one more question. Are there any manufacturers in the room? A few, 3, 4. I just want to make sure where to put emphasis. Any software developers or data analysts? Cool. All right, so evenly distributed, so we can make sure you both get what you're here for. I have 20 slides and 3 small videos. We have about 50 minutes. I expect to complete this in about 40 to 45 minutes and have plenty of time for Q&A in the end. So please think of questions and keep it with you so we can take that. Also, to put this in context, everybody's familiar with Industry 4.0, smart manufacturing. Under that umbrella, there are various technologies like 3D printing, like machine vision, one of which is factory data analytics. Factory data analytics is the lowest hanging fruit when it comes to Industry 4.0 or smart manufacturing implementation, because it is for the data you already have. You're not being asked to put hardware in place. You're not being asked to do things differently. It's the data you already have residing in various systems in your factory. It could be ERP, MES, QMS system. It could be Excel sheets, Access databases, in people's heads, right? And to get all that data make sense so you can run your factory more efficiently is what factory data analytics is all about. But when we say factory data analytics, so Industry 4.0, smart manufacturing, factory data analytics, and in factory data analytics, you have multiple strands. As you walk around the trade show, you'll find companies doing CRM, for example, demand forecasting, for example, looking at maintenance of assets. Those are various ways or you can use factory data analytics. What I'm going to talk about today is the entire system, the entire factory. It's the digital twin of the entire factory. So the attempt is to use factory digital twin technology. You should be able to implement what is known as data-driven manufacturing. So every decision on the shop floor, whether it's execution-related, planning-related, looking at alternative strategies to improve your product flow, material flow on the shop floor, and fulfill your customer's requirement, reduce your cost structure, all that comes under this factory digital twin. So it's not just addressing one small application. It's everything you need to know to be able to run your factories more efficiently. So that's the difference between factory digital twin and some other digital twins that you may have come across in the past. As an example, the most common digital twin that people come across is product digital twin, right? So as an example, aircraft engines. They have digital twin of that, and given the ambient condition and your throttle setting, it tells you what's going to happen with the engine, right? There are process digital twins, and that would be something like physics-based machining. So you have a CNC mill, and you're cutting it given the material of the part, which may be titanium, whatever it might be, and the cutting tool and the speed and feeds, it predicts how you're going to model that process. So that's process digital twin. This is factory digital twin at the factory level. So I hope that's clear. The difference is digital twin is digital twin, but there are nuances there. Okay? With that background, I'm going to talk about first the definition of factory digital twin, just to make it very clear. There's a lot of effort at the national level, at the national labs, various national institutions, and so I want to make sure you have some reference. When you go back, you can go refer to that material if you wanted to know deeper ideas about that. And then I'll talk about how our factory twin plays into that factory digital twin space. So our company's name is FactoryTwin, and we have a platform which is twinning the factory for small and medium-sized companies. Then we'll talk about how you can simplify factories. One of the problems with manufacturing is that factories are very complex. And you might say, oh, I only make, I don't know, let's say, O-rings, right? But they are variations. I just make fasteners, but you have 30,000 SKUs, right? I have only 30,000 square foot of space, but you have 40 different pieces of equipment, 30 different operators with different skill set. And every machine, every operation requires different skill set. So it becomes pretty complex pretty quickly, right? So how do you simplify factories? So it's easier to understand, not just for the individual functions within a factory, like buyers or production planners, but for the entire staff and also to the leadership. And anybody from outside can go in and look at factory digital twin output and see that you can simplify and understand factory much better. Then I'll go over how you can use factory digital twins to improve productivity in your factory. So all the strategies that you are familiar with on a shop floor, you can model them and simulate and run scenario analysis to see what the output is going to be given the knobs you turn on the digital twin, and then what the output is before you actually go and implement. In fact, you can even expedite things like lean implementation using factory digital twin. And that's a question that I get asked very often. Is factory analytics or smart manufacturing replacing lean? So we can, if there's a question, we can address that later. But the real issue is both lean and factory analytics are representing mathematically or physically what is involved in the factory physics. So there's no difference. It's just that lean has its own terminology. It's been used so that everybody understands it. And the principles that come out of lean support what comes out of mathematical modeling of the factory. So we say that factory digital twin or factory twin actually enhances and expedites lean implementation rather than being something that replaces lean. Okay, and I'll give you a couple of examples of that as well. And finally, we'll conclude. Okay, and in the demos that I'll give you, the little videos I'll play of FactoryTwin, there might be company names there that you might seem familiar. Make sure you understand that I'm disclaiming that any of data is true. It's all made up just for the purposes of the demo. If you want to know a lot about digital twins, this report came out just last year. Foundational research gaps and future directions of digital twins. This came from National Academy of Science and Engineering. A lot of detail, a lot of good stuff if you want to learn everything about digital twins. Unfortunately, it doesn't cover too much of factory digital twins. A lot about product twins, a lot about biomedical applications, but not so much about the factory itself. So as you notice, when you read through this basic definition of digital twins, this is a twin which is a representation of a physical system dynamically updated with data from its physical version, has a predictive capability, and informs a decision that realizes value. So you're not doing technology for technology's sake. It has to be used to give you value. It also mentioned there should be bidirectional interaction between the physical and the digital twin. And this is one place where factory digital twin breaks down because nobody wants any software to come and start meddling with my ERP system, right? So that's why I say practical and affordable digital twins. Now, you could go and do it, but most often than not, your company, your ERP vendor, your IT system would not want you to willy-nilly write stuff in your database in the ERP system. We have been at it for quite a while. We started this company in 2017. At the time, we didn't even know there was something called digital twin or factory digital twin. We were just trying to solve the problems people come across on the shop floor. To give you a little bit of background about myself, I ran factories, small factories, large factories, all the way to CEO level of an aircraft company. And I've seen the same problem all across manufacturing. If you go to general factory floor, things are happening like they used to happen 50 years ago. Still brute force, still intuitive, based on tribal knowledge, particularly in small and medium-sized manufacturers, right? So we started building this for a long time. We have done a lot of academic work, collaboration with the universities, but now we have made it into a product. Our latest publication was middle of last year in the Institute of Industrial and Systems Engineers, talking about how you use digital twins to optimize production planning. But as I said, Factory Digital Twin can do a lot more than planning and scheduling. We also won for our algorithm Small Business Innovation Award from National Science Foundation, both phases 1 and 2. So that kind of tells you why you should listen to me. Another thing, just to differentiate between all the other data systems and the insights they provide that are currently popular. So you can go from left to generic visualization tool like Qlik that comes with some ERP system people can attach. You got Power BI, you got Tableau, you got custom dashboards you can build, Excel sheets, even MES and ERP modules. Like if you're more interested in scheduling and planning, you would probably get something like a integrated business planning or APS module from an ERP system. But Digital Twin does way more than that. It's very differentiated, can handle scale and complexity of operation, which is way beyond anything that MES and ERP can do in a reasonable amount of time. You don't want to be running your ERP system overnight to run a scenario analysis. You want those answers quick, in seconds, right? The fact is, today, if you have an ERP system in your factory, it schedules overnight or several hours of scheduling. You come in the morning, unpredictable things happen. 3 operators show up sick or don't show up because they call in sick. The machines go down, supplier didn't deliver the parts, few parts went on quality hold. What do you do now? If you try to do the traditional ERP scheduling again, it's going to take a few hours, or at least an hour or so. With digital twin technology, you can run in seconds, and you can run multiple scenarios. You can do dynamic analysis and scenario analysis as well. And on the x-axis, it also shows, since it's specifically targeted for manufacturing for the shop floor, it's easier to implement. You're not worried about all the other bells and whistles like accounting and HR data. You're only worried about operational data. And by the way, if there's one thing you take from this presentation is that our secret sauce and why we've been able to do this is because we have reduced a factory to 470 variables. That's the magic number. 470 variables. Every factory has those 470 variables if you're running that factory efficiently or even reasonably well. Now, those all variables may not be in your ERP systems. They may be in MES, QMS, Excel sheets, Access databases, people's heads, offline, PDF files, Word documents. But if you don't have those 470 variables, you don't have complete information about your factory. So Factory Digital Twin captures the interdependencies and resulting dynamical output from those 470 variables. So talking a little bit about FactoryTwin itself, everybody that you talk to that wants to implement factory analytics or any tool thereof, they will say, well, I don't know how good my data is. And it's garbage in, garbage out. So we have with FactoryTwin a module called Factory Validator. It hooks up to your data with multiple streams and gives you data integrity checks. And this can be on demand or real time. So as data is being collected from POs coming in, parts being delivered out, it captures all the inconsistencies and gaps in the data. So if you are looking at the output from the FactoryTwin, you better make sure that your data is complete. And if the data is not complete, make sure that it's not critical data. So what do I mean by critical data? Out of those 470 variables, some things are critical, like standard times. If you are building a part, there has to be a bill of material. If there's a bill of material, it should identify what is make part and what is buy part. If it's a make part, there has to be a router for it. If there's a router, every operational step must have standard times, who's skilled to do that operation, which machine to do the operation at, and clearly defined. If it's a bought part, you should have what supplier you're going to go buy it from, what is their lead time, what is the unit price, what is the history of performance from that supplier. Right? So those are critical pieces of information. But then there are not so critical pieces of information, and that could be things like supplier location. Now, if you are interested in seeing the spaghetti of your parts moving from globally to your shop, you may be interested in that geographical location of the supplier. But if you're interested in seeing how the supplier is performing and how it's impacting your factory metric, you don't need it. So it's not a critical variable. So FactoryTwin's module factory validator identifies the criticality of a variable and the consistency and accuracy and gaps in those variables that you have or you don't have. Does that make sense? Okay. And then another module is digital CI, as I was saying, continuous improvement. Smaller and medium-sized factories, think about that. You have a 50-person factory. There is not going to be a CI team. In fact, you may not even have buyers. I've seen plant managers placing the POs and chasing parts. So can this tool help me do my job much more efficiently? And that's one of the reasons we have built this. So if you don't have CI manager, you want to implement lean, what is the first thing you do when you implement lean? Anybody?
Define.
Excuse me?
Define or measure?
Well, even before you do define and measure, what do you define and measure? So lean implementation, if you read Mike Rother's book or Lean Enterprise Institute's, Learning to See, which is like a Bible in lean, first thing you need to do, and a lot of companies don't do it very well, is value stream mapping. So you can see the movement of part across your factory in a systemic sense, right? Value stream mapping takes time. If you do the traditional way, how is it done? You sit in a room, there's a wall, you put the stickies in, people make estimates of what the queue time is, what the setup time is, what the process time is, and they're making guesses. Why make guesses? It's in your system, right? We can give you on-demand push-button value stream map through factory digital twin technology. You don't have to spend time to do as-is value stream mapping. What you need to do is focus on future state value stream map. That's where your judgment, your creativity comes in. Collecting data to give you as-is value stream map and taking 2 months to do it and taking away hours and hours of your expert's time is not worth it. They should be spending time in improving the factory in the future value stream map, not in defining the as-is value stream map. So digital CI module can do that sort of thing. We have sales and operations planning. Again, small company, I've seen larger companies with a whole department of sales and operations planning. There'll be a dozen people managing a billion-dollar company's sales and operations planning, working all the time, collecting data, generating Excel sheets, doing PowerPoint, and then running these demand planning and resource utilization and supplier risk assessment and inventory exposure week after week after week. Why? It's all in your data. Click button, it's all there. You can run your S&OP meeting using digital twins. On demand, anytime. Another example, production meeting. How do you do production meeting? There's a variation in how large and small companies do it, but typically the way to do production meetings is in any factory, you download Excel sheets from your ERP system or MES system, or you may have Excel sheet to track parts. You don't have an ERP system. And then you call people, or they sit around a table and say, where is this part? Is this late? Why is it late? Is there a quality check on it? Well, we can automate all that stuff. Why do you need to have all that? And by the way, by the time you print out your Excel sheet from ERP, it's already obsolete. Parts are moving, parts are coming in, parts are being shipped, right? So you can run production meeting using a live data stream, which is configured to help you run your production meeting. Same thing, sales and operations meeting. Scenario analysis. So as I was saying, you have a scheduler. Doesn't matter what scheduler it is, whether it's FactoryTwin scheduler or it's ERP scheduler. Scheduler spits out, this part needs to go on this machine and this operator is qualified to run it. But then you go to the shop, unpredictable things happen, as I said at the beginning. People will call in sick, parts will go on quality hold, supplier will not deliver the details you need for that day's operations, machines will go down. You have to do dynamic scheduling, and you don't want to wait for an hour to reschedule. Your shift is on now. Production supervisor is asking for that schedule. Do it in seconds. Don't do it in hours and overnight. So these are some of the other things that Factory Digital Twin can give you. So you can think of Factory Digital Twin as a digital representation for everything that goes on in your factory. So why can't you make decisions and run your meetings or have discussion about strategic choices using that instead of trying to either use your gut, tribal knowledge, or do preparation to run any meetings. We had a customer that was running, every 2 weeks, they were running inventory meeting. They had a big cash flow problem. That inventory meeting required one analyst from finance group, one analyst from supply chain, and then some other groups who would sit together and generate the data that would take them several days to do that meeting every 2 weeks. It's all in digital twin. You run that, no prep needed, everything you need to know about inventory, aging, bucketization, active, inactive, obsolete, and excess, all there. And it's real time. So now I'm going to go into simplifying the factory. So before we even get there, why aren't small and medium-sized manufacturers using data analytics? I'm not even talking digital twin right now. I'm talking just data analytics. Why aren't they using it? And there are multiple reasons. One is the lack of internal talent, or if there is talent, they don't have time. Affordability of tools. If you were to go and say, I want to implement digital twin, and you Google it, and you'll see some big vendors' names come up. They are costing you millions of dollars, years of implementation. Small manufacturing companies, they need something implemented quick with ROI in months. So you can't afford to even implement in months. You want to implement in weeks. So that's another reason they don't do it. Then there are resources which are internal, tied up in implementation of these things. If you implement, anybody who's done ERP implementation, how many people have done ERP or MES implementation? How many people get tied up from your companies to just help do this, make meeting weekly? That's one reason why small, medium, we've been through this pain before in ERP. I'm not going to do it again for analytics. So the software should address those issues. Data integrity, I also mentioned, data garbage in, garbage out scenario. And then lack of affordable tools, and this is where we come in. To give you some concrete reason why factories are complex. This is one of our customers with $45 million annual revenue. So it's not a huge factory, right? They have 1,520 manufactured parts, 600 finished good parts, 70 platforms, 90 customers, 28 part families, yada, yada, yada. And they have schedule fluctuations happening. They have demand ramp up and down happening throughout the year. They do new parts through NPI process, and they have long lead time. All that makes the factory very complex. And if you are thinking of an industry where you have high mix, low volume, it gets even worse. So that's why factories are complex, not because they're making very complex parts, it's because of these different number of things, the scale and complexity of all of these. So what I'm putting here is maybe a dozen of the 470 variables I put earlier, talked about. And as a result, there's a lot of low value or non-value added part that factories spend time on. I mentioned getting ready for meetings as an example, right? There are several other things. There are people who are looking for individual applications like giving you alerts for calibration of tools, for consumables getting closer to expiration. So you could buy a bunch of these disparate software application, or you can implement digital twin that does it all. So for simplification, here's a good use case. If you go to a factory, reasonably complex factory, so I'm saying anything which has more than 50 employees on the shop floor is reasonably complex. You go to that factory and you ask them, frustration on a day-to-day basis, and you hear, I've been working here for 10 years, but then my customer calls and it takes me so much time to figure out where it is. Especially if it's not something right on top of your mind on that part. It takes weeks to understand, value stream mapping. I have an expert, there are oak trees in every organization that have all the knowledge. I go to them to ask, is this part going to be delivered? I don't know what's going to happen, right? What are the problems with this part? What are the problems with the supplier? So digital twin can give you, and I'm going to now play a video clip, which is basically screenshots from the twin, just stitched together. So very simple, quick video to describe any piece of knowledge you need for a part you make in your factory at your fingertips. And the crucial thing that I showed there is plan for every part. That's a dream for a lean factory. Toyota Production System talks a lot about having a plan for every part. But if you're making hundreds of parts with thousands of components, who's got plan for every part? Maybe you track only the top 10. Maybe you do the top 2. Sometimes you don't do any. Here you have plan for every part at your fingertips. So this simplifies the factory. You're not solve any problem. You can look at the value stream map. You've identified the Kaizen opportunities also in an automated fashion. But then you have to execute. So that's one thing I refrain from doing, which is to say that this software or this technology is going to save you, so much or give you so much of improvement. If the customer says that, that's okay, but we don't claim that because software only gives you guidance on what to do. You still have to execute. And so it's your team's skills in executing what problems have been identified by the software. Now let's look at some productivity examples. Typically, you can expect, if you have not done factory data analytics, you can typically expect double-digit improvements in your metrics. And we have had customers where we've seen 50% improvement in cash flow as an example. And that's because if you don't focus on some area, you haven't done any analytics, the first time you start using those tools, you're going to start to see major, major improvements. You can also package digital twin software as data assistant for each function in your group. And that really improves productivity for factory support functions. So if you're a buyer, there's a lot of studies out there, including by some larger consulting firm, that show 50 to 65% of a buyer's time is spent in just identifying what parts to chase, what POs to place, where there are supplier risks, how to find the right suppliers to send the RFQs to. And that can all be automated. So data assistants do a great job. Notice I'm not using the word copilot or AI. Not needed. So another use case. This is a classic problem. I have bottlenecks. They change over time. I want to look at the capacity utilization. Is it because of equipment, fixtures, operators? What is causing it? What can I do? You have basically 7 main strategies that are listed here to deal with the bottlenecks. Some are more expensive than the others. If you have a bottleneck at a station or for a skill set, what do? You can do the expensive brute force approach, which is to hire people or buy more pieces of equipment. But what happens if next year you don't have demand for that? So there are other things you can do, and you can experiment using software like this. So I'm going to run another small video to show how digital twin technology can be used to deal with capacity constraints in an affordable and practical manner. Okay, so the heat map you saw is a pretty standard way of describing bottlenecks in a factory, right? On the y-axis, you have all the resources. They could be people, or they could be machines. They could even be fixtures. And x-axis is time. So you're trying to see where you can eliminate bottlenecks and how you can level load if your customer agrees to it, or if you're willing to put some stuff on stock. But then beyond that, there are many ways you can handle bottleneck scenarios by doing things which are more effective and less costly than hiring people or buying machines. Okay, another use case now we're going to do is shop improvement. So typically, if you want to improve your shop, there are 2 major things you can do, and the focus should always be there. If you go to a shop, I used to be a consultant years ago, and I used to run plants for many, many years, then I became a consultant, and now we are running FactoryTwin. You would go to a shop and say, if you're not focused on constantly reducing the lead time in your shop, and constantly reducing the cost structure of major parts in your shop, you're not getting more competitive. So that reducing lead time in the shop and reducing cost structure, how you can do it using digital twin. So there's nothing here that you don't know. That's the beauty of this. There's nothing here that factory personnel do not know. They are not able to execute because it takes so long to get all the data, so long to figure out what the real issue is that needs to be addressed. If you're looking at cost reduction, that's exactly what you would do. The additional thing you can do here is that you're not looking at just specific part number. The first view that you saw of future revenue versus margins allows you to pick the right part to work on. And beyond that, it's common sense. It just speeds up the way you would implement that. So with these 3 use cases, I hope we're able to show you how you can speed up non-value add, or let's say directional guidance on what needs to happen, or what issues need to be addressed or better understood in a speedy fashion. But then execution is up to you, up to the shop, right? So you still need smart, creative personnel, but you probably need a lot less energy to institute any of these initiatives or projects. And you know, the ROI and the business case calculator is built in for everything you do, as you saw for the cost reduction. If you could negotiate that material price reduction, that gives you so much increase. You can go and look at other opportunities, like for labor cost reduction, and see the same thing. Okay? So now let's go to, we're at 50 minutes note, so I'm going to conclude very, very quickly and then open. Are there questions, by the way? Any questions so far? Okay, so let me just finish the conclusion and we'll get to questions. One of the things we did a survey for aerospace small, medium shop companies with, in partnership with Aviation Week, which is the premier trade magazine in aerospace. And this is what we found, that of the smart manufacturing technologies people were thinking of investing in, this realization is coming that data analytics is the low-hanging fruit. So you can see more than 70% said, this was last year, said that this is where they're investing in or intend to invest in, more than even 3D printing or other technologies in smart manufacturing. And here are some, from our customers. So like I said, we never claim that a digital twin technology implementation or our software is going to give you huge benefits. We just conceptually know it should give you huge benefits. And then the customer response and customer testimonials bear testimony to that. So I'm going to conclude with this. We've got some time for Q&A.
So the first question is, as it happens with ERP, CRMs, and that, besides the implementation, which is a nightmare most of the times, it takes a lot of manpower to actually run. How about FactoryTwin?
Manpower to maintain or?
To use it.
To use it.
I mean, do you envision this as every user has to do its own part by entering its own portion of data, or you have like an operator who's collecting data from different sources and putting it into feeding the system?
Okay, so the question is there a lot of manpower involved in actually using the tool, as it is the case with ERP systems where you have to look at collecting data and so on. So this is sitting on top of ERP system and other databases, right? So you're not using any time additional or resources additional to what you're already doing, right? In order to use this tool, first thing I should mention is our customers use this tool to train their people. If you have a buyer who comes in and may not know your industry, the tool and its user handbook actually tells you what to do. So it's almost like a training tool. So you can get the people up to speed in their job much faster, so they can shadow somebody experienced and use the tool and they can run much more quickly. So it actually helps, using the tool helps in reducing the manpower requirement to come up to speed to deliver these things. Secondly, a lot of focus has to be made, and that's one thing where I think we do in some ways, if I can say so myself, improving the user experience so that it's intuitive to use the tool. So you're not doing something which is hard to do and you have to need a huge training material and constant training. ERP requires experts, right? Not everybody can go and download data. You have experts, you have super users. This doesn't require that. Because when you go for this and you go to the buyer functionality or the buyer data assistant I talked to you about, it's very intuitive and easy to use. So you don't need to put any additional effort. All it does, it reduces time spent in repetitive, mundane, offline tasks. Okay? Any other questions? Yes?
Can you please touch upon the risks from type 2 errors using simulation models for like the real world systems?
Can you please repeat that?
Can you please touch upon the risks of type 2 errors for using simulation models for like real world decisions.
Can you expand on the type 2 models?
So like we are currently actively looking into digital twin. We are running a proof of concept, and one of the biggest risks I see is setting up a system that gives us the wrong problem to solve in a scenario analysis, right? And then we go ahead and we start implementing these solutions. So for example, during the video that you played, setting up new stations for the CNC line. What if, and again, the irony of the whole situation is the solution is what if that problem that is being identified is the wrong problem that is being identified through the model, because how it was set up, not because of the tool itself.
Yeah, so one difference, so I see your point. So the question is there a likelihood for error in the output or the guidance that the tool gives you because you're setting up the problem incorrectly? And so the way I describe this to you is that factory digital twin, it's not modeling a specific action like inventory management, because then you have to make assumptions about what goes in, how the interaction will occur. It's actually reflecting the factory physics. So if you were to go and check for Little's law, it should conform to that. And the reason it would do that is because you have captured the physics of the factory in your mathematical model. So it's a complete system level model. So you're not even setting up a problem to solve. You're setting up a whole factory, and you're saying, oh, what is my problem? And so the problem definition is coming from the tool, and problem solution avenues are also coming from the tool. So you're not making assumption in setting up a problem.
So just to follow up on that, thank you for touching upon the question and addressing, like, because what you said I resonate with. The next thought that my brain talks about is, what about how this data is being collected? Because if the MES and ERP systems, any company with multiple systems integrated within, is not taking real-time information into the digital twin, and people meddle with it, and now there's manual errors into inputting that data, what would you say about, like, what are your thoughts about that thought?
Okay, so the question is, what about the problems in actual data collection? Are you collecting the right data? Are you integrating the right data? And if you're not doing it, obviously the model is going to be wrong and the answer will be wrong. And that's a very good question. So that's a really, let's say, a point of caution for manufacturers who are choosing any software, not just this software, any software, in making sure that before you do any software implementation, you have to look at your processes, standardization. So we don't claim to be a SaaS company. We are not a SaaS company. We don't go and implement software and charge subscription. We are a consulting company that gives you the software tool as something that you can help improve your software. So 5 or 6 years ago, we were doing operational improvement with our small and medium manufacturers, and we would do consulting for like 6 months, and we would leave with a PowerPoint deck and say, goodbye, you're good. We solved your problems. Nobody followed up, or very few people followed up, and that's pretty unsatisfying gig, right? So we said, why don't we give them something that they can use over time? Give them a tool, and we build a tool in collaboration with them. So that consulting engagement that used to be 6 to 9 months is now 6 to 9 weeks, because a lot of this is coming off the shelf. And every shop has a nuance, right? Every shop has a difference. No two shops are exactly alike. The 470 variables I talked about, they have variations. They have the way they're collected, how you're standardizing, how you're archiving, all that stuff. So you really need to work with somebody who understands operations. So we call ourselves operations experts. We don't call ourselves software experts. We use digital technology to improve shops, but we work with companies. The first thing you want to do is we do a workshop where we try to understand what is your standard process of collecting data. Even collecting shop times may be varying over time, right? What are you doing? Some people are doing Google Docs, some people have barcodes, some people are just writing on a whiteboard, some people have got Excel sheet. How good is it? How reliable it is, right? So you have to also understand the sensitivity of that variable to the outcome. Some variables may be critical, but the sensitivity is not there. So, hey, if it's off by 20%, we're still good. But there's something you need to be very accurate. Setup time, for example, needs to be fairly accurate. You know? So yeah, good question.
Thank you.
Yeah.
If you don't mind me asking, what is your average shop size? Like you're talking about CNC machines, what is it, like 20 machines, 50, 100, 200 machines?
So you use analytics in general, not just our tool, not just digital technology. You would like to use analytics when your operation is complex enough. And just from all the experience we have had with dozens and dozens of shops, you need to be in a range of, that's why I said like maybe you need 30 to 50 people minimum, right? If you have a garage with 3 machines, you don't need analytics, right? So we say our sweet spot is $25 million revenue to $250 million revenue, but we have customers that are $2 billion company, and we have customers that are $8 million company. So it depends on the complexity.
What we found as a machine distributor is that small shops, they're very neglected to connecting the machines to anything. So in terms of data collections, cycle times and machine data, it's very difficult to get it because they don't want to plug the machines to the network or the internet or anything else. And this is something that will have to be addressed.
Yeah, and that's the part we address in the implementation phase. So we have partners who would help you. Let's say you need to implement barcoding in your warehouse. We have partners who we have worked with. We know how they collect data. They would go and implement in a couple of weeks. Usually actually less than a week for warehouse barcoding type stuff. So you need to do all that infrastructure stuff first before you use any software. And for smaller companies, you're exactly right. There's a lot of lack of data integrity and a lot of data completeness, or even the basic data infrastructure that is missing. By the way, if you come to our booth, 236064, 236064, it's also on the pamphlet that, I don't know if it's on the pamphlet. It's probably not there. 236064 in North Building, 3rd level. We have a little survey to do if you're a small factory. And you can do that survey and ask the questions, how many people do you have? How many bill of materials you have? How many parts you have? What is the depth of your bill of material? How many steps in your router? That determines the complexity. And then we have data maturity assessment. Do you use the ERP system? Do you have standard time? And based on that, we can place you in a 2x2 that tells you where you would stand with respect to your peers. And you can see if it's urgent for you to do something about it. Any other questions? Yep.
I was wondering, what is the computing power needs for a system at like $1 to $2 billion revenue organization with like just about 40 to 100 product units coming out every year?
Yeah. So let me start with an anecdote. You all know Boeing company, right? It's public knowledge, so I'm not saying anything that I shouldn't say in public. You Google it. Boeing had an agreement with a major software vendor in 2015, 2016 timeframe, $1 billion 10-year project to digitize all their factories. Nothing happened. You can go back. They are going back to digitizing individual factories. One of the reasons is computing power, right? So you should think of $1 billion company, like we have a customer, this is $2 to $3 billion company. We are implementing this software at the factory level. And individual factories are still a couple of $100 million factories. So computing power required is not much. And speaking of computing power, just a personal experience thing, 20 years ago, I used to run plants. Small plant, 200, 250 people. You could not do this sort of thing 20 years ago. For 2 reasons. You didn't have the computing power, you didn't have efficient algorithms. In those 20 years, computing power, maybe 30 years, computing power has gone 1 million times just by Moore's law. You can do 2 to the power 30, you'll get about 1 million. Yeah? It's gone up 1 million times. Plus, algorithmic advances have also improved about 1 million times. As a result, you can run things 1 trillion times faster. So this is the time, right? We are in a great times right now. 1 trillion times faster factory data analytics. So what happens is when we implement this at a factory, which is, let's say, $100 million revenue, all you need is a high-end laptop. Server with an Intel quad core, you're good. You may need a lot of hard disk, but hard disk is cheap, right? Because you have to keep saving these simulations over and over again. But Intel quad core will do it for you for a $100 million factory.
A last question. Can you say anything about cost? I know it depends, but cost of the system, approximately?
So the title was Practical and Affordable Digital Twins for Small and Medium-Sized Companies. So imagine our smallest customer with $8 million revenue. They are not going to pay $1 million or $100,000 for this. If I can justify to them that in 9 months, 6 to 9 months, they'll be in a break-even point, they'll recover their investment, that's sufficient, right? So what that value is can be specifically calculated, but I'll tell you a rule of thumb. And this is, again, something because I'm not a SaaS company. So I'm thinking from user's perspective. If you were to do a basic dashboarding of your data, Power BI, or Excel sheet even, you get some engineers, have them spend some time, collect the data in ERP and implement it. You can start to get better and better. So let's say you had to hire somebody with STEM background who could do implementation like that, right? So 1 FTE. FTE, everyone knows what that is, right? Full-time equivalent. What if I gave you this tool for 1 FTE? You don't have to hire one person to do dashboarding, and you get so much more.
On a perpetual license.
Sorry?
On a perpetual license.
No, that's the implementation, okay? And then licensing would be, let's say, 1/3 of an FTE, right? And you're saving tens of FTEs on the support functions, just by implementing without even seeing any benefits to your KPIs. KPIs come as further gravy to what you're getting from this tool, right? So this is something I learned over experience, that you can't go to a shop and say it costs X amount of dollar. You have to relate to what it means for them as an opportunity cost. So the opportunity cost is in terms of FTEs. If I say I give you for 1 FTE and charge you half FTE subscription, good to go. Anything else? Okay, well, thank you so much. I really appreciate you coming and taking the time. Visit us in the booth 236064. If you drop your card with me, we can send you the presentation also. Okay? Thank you very much.